going to take a look at the relative strength of acids and bases. So the main idea here is that when you put a substance into water, it can interact with the water and either increase the amount of hydrogen ion that's present in solution, or it can increase the amount of hydroxide ion that's in solution. And as you'll see in a future video, that there's a balance that exists between the amount of hydroxide ion in solution and the amount of hydrogen ion in solution. So let's take a look at a strong acid versus a weak acid. So here's kind of a depiction of what happens when you put a strong acid into water. Right? So that's our picture over here. When you put it into water, every single one of the hydrogen ions is going to separate from the anion that's present there. So we can represent that in a formula. HA goes 100% to H plus plus A minus. So every single one of those is going to break apart, and that's what makes it the characteristic of a strong acid. Now a weak acid, all right, so that's our one over here. Here, when I dissolve this weak acid into water, very few of the hydrogen ions and conjugate base ions, the A minus ions or B minus ions, will break apart. And so if we were going to do that in another equation here, we would say that it goes in that direction less than 1%. So it would be the characteristic of a weak acid to H plus plus B minus. And again, you can see that in the two pictures that are presented here, where all of them have separated versus a situation where most of them have stayed together and very few actually break apart. Again, less than 1%. Now, it would probably be a good idea at this point to also take a look at what's happening to these things when they go into water. All right, well, here's a depiction of acetic acid reacting with water. Now, acetic acid is a weak acid. So what you're going to get is the hydrogen ion coming off. Right, our definition of an acid is going to donate a proton. And so that proton is then going to go into the water. Well, a proton basically going into the water, the nucleus of a hydrogen going into the water, is just inviting something with negative charge to come around and grab onto it, or to attract with it. And that's exactly what's going to happen. A water molecule is actually going to be involved in taking that hydrogen ion off of there, the proton. The proton never really kind of exists by itself. There would always be some kind of interaction going on between the proton, the hydrogen there, and the water molecule. And what ends up happening then is that the proton comes off. So now we're looking at the picture over on the other side. The proton comes off and is now associated with the water molecule and is called a hydronium ion. Which would have a net positive charge. And then our anion, or our conjugate base, would have a negative ion because it lost that one positive charge. So this is kind of what happens. And in an equation form, the way we would write this is the acid, and I might as well, since it's a weak acid, let's use the Kb or Hb like the prior one, plus water. And since it's weak, it's going to go very small degree this way. So again, less than 1% in the forward direction, and forming hydronium plus the conjugate base of the weak acid, so the B minus. All right, so hopefully this gives you a better idea of, first of all, what happens to acids when they go into water, and secondly, the difference between a strong acid, which would ionize 100%, so it'd be the same equation as what we have up here, only we would have it going 100% in the forward direction. versus a weak acid in which very few of the acid molecules actually will break apart and form the hydronium ions and the conjugate bases.